We're going to do 5.3 transformations of sinusoidal functions today. In class we broke this into 2 lessons, but I'm just going to do both of them in this video. So the first part of this lesson is learning really about how to graph sort of these more complicated sinusoidal functions that have a variety of transformations, including a phase shift incorporated into them. Okay, so we talk about sinusoidal functions in terms of transformations, and you know your transformations already. I know you do. The A, the K, the C, the D are all transformations from the graph of the original sine or cosine function. So A is the vertical reflection. No, sorry, A has the reflection in it, the reflection on the x-axis, but it also is the vertical stretch or compression. K relates to the horizontal stretch or compression. D relates to the horizontal translation, and C relates to the vertical translation. But we also talk about what I call characteristics of the sinusoidal function, and these are the characteristics of the sinusoidal function, and they relate to transformations, but really characteristics are what is a particular feature of the graph, not the original one, but the final one. So A, this is absolute value here, which I know you learned last year. Absolute value just means you're taking the positive, whatever the A is. So amplitude relates to vertical stretch. Phase shift relates to horizontal translation. C, vertical displacement, relates to vertical translation. And P is the tricky one because P here is not in here. Okay, so period P is related to the K, but it's not equal to the K. K is the in sinusoidal functions is the horizontal stretch or compression, but really what it is, it's the number of cycles in 2 pi. And we can get the K value if we know the period, okay? Or we can get the period if we know the K value. So for instance, if I gave you y equals cos 2x, K is 2, so we know that there was a horizontal, let me think about this, it's a compression by a factor of 1/2. So that would be transformation talk. But if I were to talk to you in terms of the K value, this K value is 2, which means there are 2 cycles of this over 2 pi, which means I would draw cos twice, and I would end up at 2 pi, which means the period of 1 cycle is half the period of the original. So how do I figure that out? I would have P equals 2 pi over K. I can see my K is 2, so the period would be 2 pi over 2, so the period is pi. Okay, so definitely period and K are related to the horizontal stretch or compression. Okay, all that aside now, all we're going to do in the first part of this lesson, oh, I thought I cleared it, is we're going to figure out how to graph some of these more complicated graphs. So we'll start out pretty easy here. We're going to graph this one. The original function is a cosine function. It's been shifted pi by 4 units. If it's positive, it's been shifted right. If the phase shift was negative pi by 4, you know cosine was shifted left. So in this case, positive, and we know that the period is 3 pi by 2. Okay, now it's very, very difficult, I think, to graph these if you're just sort of guessing at your scale. So we're not going to do any guessing. We're going to follow this sort of tried and true method, if you will, of setting up a scale. Okay, we need to know what our increments are going to be for our graph. So what we're going to do, we're going to take our period and we're going to divide it into quarters. And so when I write P over 4, I'm really talking about quarter period. Okay, and I want to know what my a quarter of the period of the graph is. So I'm going to take the original period, 3 pi by 2, and I'm going to multiply it by 4 on the bottom. That's going to take 1/4 of it. Okay? So 1/4 of my period here is 3 pi by 8. That's the first thing I'm going to do. The second thing I'm going to do is I'm going to look at my phase shift. So my phase shift is pi by 4. And then what I do here, and I know this is kind of funny because you're not really sure why you're doing this, but I'm going to look at the denominator of that fraction, which is my phase shift, and the denominator of my quarter period. And you would reduce this if it needed to be reduced, but it can't be reduced. So I have these two numbers here, these two denominators, and I want to take the lowest common denominator of these two. So the lowest common denominator of 4 and 8, and remember, a common denominator is a number that both of the denominators will divide into evenly. So it has to be at least as big as your biggest number. So does 8 work? Yes, 4 goes into 8, 8 goes into 8. So I know the lowest common denominator of 4 and 8 is 8. So that means I'm going to now write my increments on my scale in terms of pi by 8. So we got our 8, we're going to put it under pi. Okay, so our increments are going to be going up by pi by 8. Okay, so here we go. I'm just going to probably put too many on here, but that's okay for the first one. So pi by 8, next one, 2 pi by 8, but I'm going to reduce. That's pi by 4. The next one, 3 pi by 8. They're just all pi by 8s. 1 pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8, which is pi by 2, 5 pi by 8, 6 pi by 8, which is 3 pi by 4, 7 pi by 8, 8 pi by 8, better known as pi, 9 pi by 8, 10 pi by 8, which is 5 pi by 4, 11 pi by 8, which we can't reduce, 12 pi by 8, which is 3 pi by 2, 13 pi by 8, I'm just going to keep going here, 14 pi by 8, which is 7 pi by 4, 15 pi by 8, which can't be reduced, and 16 pi by 8, which is 2 pi. Now you don't always have to go up to 2 pi here. So all I wanted to do was graph one cycle of cosine function. Okay, so now that I've got my scale, this is how I start. I identify my phase shift, pi by 4. I go over to my phase shift, left or right, depending on whether this is plus or minus. So this is plus. And then I know it's cosine function. And I know cosine because I know cosine like the back of my hand. The original cosine always starts at its max on the y-axis, right? And its max is 1. So I'm going to do the same, but I'm going to shift it over. So instead of starting on my y-axis, I'm now starting at my max of 1 at pi by 4. And now what I do, and this is the critical point, is I'm going over quarter periods every time because I know that cosine goes from its max to its equation of its axis down to its minimum, back up and back up. I know the shape of cos. And I know that this happens over a quarter of the period. Now, a quarter of the period of the original function would be pi by 2. We'd be going over pi by 2. But this period has changed. It's not 2 pi. This period is 3 pi by 2. So the quarter of the period is 3 pi by 8. So I need to go over 3 pi by 8 units. Well, I can see on my graph that 3 pi by 8 units represents 3 squares or 3 increments. Okay? So from here, I'm just going to count over 3. 1, 2, 3. I'm going to be down at my equation of my axis. 1, 2, 3, down at my minimum. 1, 2, 3, back down, up to my equation of my axis. 1, 2, 3, up at my max. You should have a cosine-shaped graph here. Hey, that wasn't bad. And you should label 5 points as per usual. Now, I know that's not, all that intuitive, but what is that, 5? Is that 11 pi by 8? And 7 pi by 4. And 1. But I think you need to practice it for sure. So we're going to try it again. The key points are finding the quarter period, comparing the denominators of the phase shift and the quarter period and finding the LCD to get your increments on your scale. And then starting at your phase shift and applying a quarter period each time. Okay, let's do it. Why don't you try the next one? And pause the video, give it a try, see how you do, and then turn it back on and we'll do it together. Okay, so let's follow the same thing. I'm going to find my quarter period. So P over 4 is going to be, I'm going to multiply the denominator of the period by 4, so I'm going to get pi by 12. Okay? My D, my phase shift, is negative pi by 8, and I'm going to identify then the two denominators that I want to find the lowest common denominator of. The lowest common denominator of 8 and 12. Well, it's not 12 this time because 8 doesn't go into 12, so I have to at least double the 12, and when I do that, I see that, yeah, that gets me the 24 that I need because 8 goes into 24. So my lowest common denominator is 24. When the lowest common denominator is 24, you're going to write your increments as pi by 24. So each one of these is going to go up by pi by 24. 2 pi by 24, 3 pi by 24, 24 has lots of factors, 4 pi by 24, 5 pi by 24, 6 pi by 24, 7 pi by 24, 8 pi by 24, 9 pi by 24, 10 pi by 24, etc. And we're just going to go in this quadrant 2 because we're going to need to have a phase shift that is negative. So negative pi by 24, negative pi by 12, and then negative pi by 8. Okay, so we have a negative phase shift. So we're going to be plotting our point at our first point at negative 8. It's a sine function. We know sine starts on its equation of its axis, which in this case it hasn't been shifted up or down, so it starts on the x-axis. Now, for the second point, we figure out what the quarter period was. We go back to our calculations. Our quarter period was pi by 12. Pi by 12 is represented by 2 squares. So I'm going to go over 1/4 of my period, which is pi by 12. I'm going to go over 2 squares, and I'm going to go up to my max of 1. 2 more squares down to my equation of my axis, 2 more squares down to my minimum, etc. So there's one cycle. I'm just going to keep on trucking here and do 2 cycles. Make sure everything is going over by 2. Oopsie, don't know what happened there. By oh goodness, so 2, 2, 2, 2, 2, 2, 2. I would finish off my scale. You don't have to put every one of these on, but it's helpful at the beginning so that you know what your increments are. So I would be doing it for a while until you can get more comfortable with the process. So this was 10 pi, this is 11 pi by 24, 12 pi by 24, 13 pi by 24. We're going to label, again, 5 points, so negative pi by 8, and 0, and negative pi by 24, and 1, and pi by 24, and 0, down here at pi by 8, and negative 1, and one more, 5 pi by 24, and 0. Okay, 5 points labeled. If I had the equation, I would put it on there, but I don't, so that's okay. Okay, pause the video, try this one. The big thing here is that there is a vertical translation of 2 units down, so this is going to be a little bit trickier because you're going to have to think about that as well. But give it a try, pause the video, and then come back and I'll do it with you. Okay, we're going to do exactly the same thing here. We're going to find the quarter period, which is 3 pi over 4, and our phase shift D is pi by 2, so I want to find the lowest common denominator of 4 and 2. Of course, that's 4, and so our increments are pi by 4. Alright, so now we've got pi by 4 here, pi by 2, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, 8 pi by 4, 9 pi by 4, 10 pi by 4, 11 pi by 4, 12 pi by 4, 13 pi by 4, 14 pi by 4, 15 pi by 4, and 16 pi by 4. Okay. It says graph one cycle of cosine with a phase shift of pi by 2 and a period of 3 pi. Alright, so what we would be doing here is we would be going to our phase shift. Our phase shift is pi by 2, positive, so we're going over here. But now it has a vertical translation down 2 units. And we're dealing with cosine. So we know cosine normally starts at its max. Its max is normally at 1, but now it's been shifted down 2. So instead of being at 1, we're going to start at negative 2. Sorry, that's negative 1. And then it goes normally back down to its equation of its axis, which is normally the x-axis. But now it's going to be the vertical translation. So this is the new x-axis would be at y equals negative 2. I can put that in if I want. I can draw that in if it's helpful. You can leave it in, that's fine. Otherwise, you can just go ahead and figure out that you have to go down to 2, negative 2 on the next move. Now, how do I get how many squares is the next move over? I look at my quarter period, which is 3 pi by 4, and I can see that 3 pi by 4 is 3 squares, right? 1, 2, 3 gets me to 3 pi by 4. So from here I have to go over 3 squares. So 1, 2, 3, and I'm down at negative 2 now. 1, 2, 3, I know cos goes down to its minimum after that. 1, 2, 3, it goes back up to its equation of its axis. 1, 2, 3, back up to its max. Okay, so we've applied the vertical translation and we've adjusted for the phase shift and the period. I'm going to label 5 points again, so this is going to be pi by 2 and negative 1. This is going to be 5 pi by 4 and negative 2. This is going to be 2 pi and negative 3. This is going to be 11 pi by 4, and negative 2. And this one is going to be 7 pi by 2 and negative 1. Okay, those were the easy ones. Now we're going to go on to something a little more challenging. This one has an amplitude and a vertical displacement, as well as having a period that has changed, it's not 2 pi, and a phase shift. So we're throwing basically everything at you in this particular question, but you're going to do it exactly the same way as we did it before. So I'm just going to go ahead and figure out, maybe over here, what my quarter pi is. I keep saying that quarter period is. So a quarter of my period was, I don't know, I don't see it, let's see, 4 pi by 3. So instead of 4 pi by 3, it's going to be 4 pi by 12, because I'm multiplying the bottom by 4. So that's going to simplify to pi by 3. So our quarter period is pi by 3. Our phase shift is negative pi by 6, and so we're looking at 3
and 6 as our lowest common denominators. So I know the lowest common denominator of 6 and 3 is just 6, and so in this case my increments are going to be in terms of pi by 6s. Alright, so I'm going to go over, I've already got a scale on here. Let's just see if it's going to work. This is pi by 2. If I divide pi by 2 into 3's, then I'm multiplying my denominator by 3, so that'll be pi by 6's. So this actually works, and I'm not going to bother putting in any more numbers here. I can see that each square is worth pi by 6, and I'm going to remember that when I go to do my graphing. So now, first step always is to go to the phase shift, and so I'm going to go over left this time because it's negative 1 square, because 1 square represents pi by 6. And then I'm going to consider the amplitude and the vertical displacement. So sometimes a helpful way of thinking about this is my max is now going to be, instead of being 1 and negative 1 for my max and my min, I'm going to take the max, I'm going to multiply it by my a, which is my amplitude, which is, in this case, I believe 3, and then I'm going to add my vertical displacement, which in this case is negative 2. So my new max is going to be 3 times 1 minus 2, which is 1. Similarly, for the minimum, I'm going to say it's going to be a times negative 1 plus c. So my new min is equal to 3 times negative 1 minus 2. So that's negative 3 minus 2, which is negative 5. And I know my my equation of my axis, which is like my new x-axis, is going to equal whatever the vertical displacement is, minus 2. Okay? So I kind of know where I'm supposed to be now. I go over to negative pi by 6. I have to figure out whether I've got sine or cos. It's sine. So I know sine starts on the equation of the axis. And the equation of the axis now is minus 2. So I'm going to start here. Let's just make this blue. Okay. And then I'm going to now figure out my quarter period, which is pi by 3. So pi by 3, this is 1 pi by 6, 2 pi by 6 is pi by 3, so I have to go over 2 squares. And I have to go to my max, because sine goes from equation of the axis to max, back to the equation of the axis, back to the minimum. So over 2, and I'm going to go up to my max, which I have said is, what, 1. I'm going to go over to 1. I'm going over 2 more squares, because that's my quarter period, and I'm going to go back down to my equation of my axis. 2 more squares gets me down to my minimum, which I figured out was negative 5, so down here. 2 more squares back up to my equation of my axis, 2 more squares back up to my max, 2 more squares over to my equation of my axis, minimum, and then back. The last 2 squares is going to get me here. So I'm just going to draw my 2 cycles. There's 1 cycle. Two cycles. I'm going to label some points. So this is negative pi by 6 and negative 2. This is pi by 6 and 1. Over here we've got pi by 2 and negative 2. We've got, I don't know, I have to figure that out, so I'm not going to even bother. I'm just going to go to one I can see. Can't even see that. I think it's 3 pi by 2 and 1, and this one is 5 pi by 2. Is that right? 2 pi is 6 pi by, no, 12 pi by 6, 13 pi by 6, 14 pi by 6, 15 pi by 6, 3 goes in, yeah, that's 5 pi by 2. So this is 5 pi by 2, and negative 2. So I've labeled 5 points there. Okay, so I figured out my max, my min, I knew my equation, my axis, so I knew exactly where I was going for each subsequent point.
Okay, so for the next example, it's slightly different. We're still going to be plotting the graph, but as you can see, we've got this function g of x, and we have an amplitude of 2. We've got a period of 1. So that's different because the period is not in terms of pi. The period is in terms of real numbers. We've got a phase shift of 0.5 to the left, and we've got a vertical displacement of 3 units up. And we want to graph the function over 2 cycles. Okay, so let's do this. So as per usual, what we want to do is identify our period, and our period here is 1. So our quarter period is 1 over 4. We also want to look at our phase shift, which in this case is 0.5 to the left, so I'll put the negative in there. And then I will change that to a fraction. So that's negative 1/2. So my lowest common denominator then of the quarter period and the phase shift is, I'm looking at the lowest common denominator of 4 and 2. And of course the lowest common denominator of 4 and 2 is 4. So my increment in this case is not going to be pi by 4. It's going to be 1 over 4. Because I know my period, my x-axis, has to be in real numbers, not in terms of exact radians. Okay, so let's go and see. I need to keep my eye on my features here, so let's see if I can do that. All right, so I see here that my scale, I've actually given you a graph, and I'm going to have to amend the graph so that it does have 1/4 on it, because I'm going to need that. So I'm just going to put little halves in here, and we know that each of those is 1/4, right? Okay, so don't really need to put a number in there because you can see the four increments up to 1. Okay, so now what I want to do is I want to go to, let's see, it's cos, so I want to go to my max, and I want to figure out what my max is, because I'm going to start at my max, right? At my phase shift. My max here is, remember the formula, A times 1 plus C. So in this case, my A is 2, and my C, my vertical displacement, is 3. So my max is 5. My minimum is A times negative 1 plus C. So my minimum is A, which is 2 times negative 1 plus C, which is 3. So this is going to be negative 2 plus 3, which is 1. Okay, so I've got my max, I've got my min. I know my equation of my axis is C, we can call it C equals 3. So with that in mind, I should be able to figure out where to go. My phase shift is negative 1/2, so that's where I'm starting. I know I've got cos, so let me just change the colors here. So it's going to be at negative 1/2. I'm going to be at cos, so I have to start at my max, and my max is 5. So I'm going to be all the way up here. And then I'm going to go from my max to my equation of my axis, which is C equals 3. I'm going to do that over my quarter period, and my quarter period is 1/4. So that means I'm only going over half a square here. So I'm going to go down to 3 over half a square. Then I'm going to go down to my minimum, which is 1 over, again, another half a square, which represents 1/4. Back up over a half a square and up there. And it wants 2 cycles, so I'm just going to repeat that. So I'm going to go back down to my equation of my axis, back down to my min, halfway up, and there we go. So I would just, again, this is rough, really rough. There we go. You're going to label 5 points, any 5 points, and you're going to make sure that you've got yeah, this is all labeled, so that's good. Okay, so our last point there was at, this is 1.5, which is 3/2. No pi's here. So 3/2 and 5. Let's do this point, 1 and 1. Let's do this point, 0, 1. That's an easy one. Let's go over here and do halfway, which is 1/2, and 5. So everything's in real numbers here. So 1, 2, 3, 4. We need one more. Let's go to the original one where we started here. We went to -1/2 and all the way up to 5. Okay. All right, that's it. Okay, so sometimes it's going to be in terms of just real numbers on our x-axis. Okay, so you should be comfortable with that. You should be able to recognize when that happens because your period will not be in terms of pi. Okay, so what I want you to do now, and I'm going to get you to go back to each of these examples that we did, and now mine, I'm going to just ask you to pause the video and go back, so I'll have to figure it out. But go back to each one and come up with the equation for each one of these, keeping in mind that you know that we need the k for the equation, and we know that the k comes from the period. So if we have the period is equal to 2 pi, I don't know why I'm going sideways here. That's the formula for the period, and if I cross multiply, I get kp equals 2 pi. And if I divide both sides through by p to get k by itself, I get k equals 2 pi. Just tilt your head. You'll be able to see it divided by p. So you want to be able to use that formula, that version of the formula, in order to figure out your k, which goes into your equation. Okay, so go back and do that for the, I think there were 4 of them that we did. Find the. Okay, here we are on the very first example, and there's the equation. We used, I'll just show you down here, we used k equals 2 pi over p. I substituted in the period, which was 3 pi by 2, and then I just flipped my fraction and I simplified it. The pi's cancel, and you're left with k equals 4/3. So up here, what we've got is our k as 4/3, and our phase shift is pi by 4, and we change the sign when we put it into the equation, right? Okay, so that was the very first one. Don't worry if you don't have these brackets here. If you don't have square brackets here, I'm not going to ding you for that, but I do believe the book does it like that. Okay, next one. So there's my equation, y equals sine 6x plus pi by 8. Did you get that? Again, if we were calculating our k, which is really the only challenging part here, you're going to take 2 pi divided by your period, which is pi by 3. Flip your fraction, cancel your pi's, and you end up with k equals 6. Don't forget to change your sign here. The next one, we had cosine. We did our k again, 2 pi divided by 3 pi this time. Divide that out, and you get 2/3. And this time we did have a vertical translation as well. Okay, and let's see what this one gave us. Okay, we had a period of 4 pi by 3. I put it in here, I flip my fraction, I cancel my pi's, and I end up with 6 over 4, which reduces down to 3 over 2. So that's in there as my k. Don't forget that you have to put brackets in if you want to put the phase shift in as is. So I would be careful about that. Don't just write 3/2 x plus pi by 6. So you've got your brackets here, you've got your correct sign because the phase shift was negative, so you've changed it to a positive, so it's all good. And last one, let's see. I didn't do this one yet, so we're going to do this one together. The k is 2 pi divided by the period, so k is equal to 2 pi divided by 1, I believe. What was the period? The period was 1. So k is equal to 2 pi. Now I'll just double check that. Yeah, period of 1. Okay, so our equation is going to be y equals, this is cos. We had an a value of 2, so this is going to be 2 cos 2 pi times your variable like x or theta, and then we had a phase shift left of -1/2, so we're going to put in +1/2 here, and then we shifted it up 3 units plus 3. Okay, so notice this one, my phase shift is a real number, and so my k is in terms of pi, and you're always going to have that. Okay, you're always going to have, if this is in terms of pi, this is going to be a real number, and vice versa. Okay, all right, let's do the new part. So write an equation to represent the following functions. So we know the maximum and the minimum, we know the phase shift, and we have the period. So if we're coming up with the equation, we really want the parameters a, k, c, and d, because our basic equation is going to be something like f of x, you know what it is, a, in this case it's sine k times x plus, minus d. My bad. Minus d plus c. So we're going to put everything in there once we figure it out. Well, our a is for amplitude, and we know the formula for amplitude is max minus min divided by 2. So I was told my max and my min, I have 5 minus 3 over 2, which is 8 divided by 2, which is 4. My c is very similar. The formula is max plus min divided by 2. And if you cannot remember, like you need to memorize that. If you forget it on a test or something, this is the way I want you to think about it. Just let me finish this here. So this is going to be 1. Your c, this is your vertical displacement. This is like your halfway point. If we go back to this graph, right? This is where the graph gets cut in half horizontally. So we know it's the average. It's the average of our max and our min. So we can just use the average formula, which is add the two numbers together and divide by 2. Okay, so you're adding for this one and you're subtracting for amplitude. Okay, so I've got my a and my c. I need my k, and I know that you know that k is 2 pi divided by p. So our k in this case is 2 pi divided by 2 pi by 3. When I flip it and multiply, I get 2 pi times 3 over 2 pi. Cancel the 2 pi's and you get k equals 3. So far so good. I've got all but one. I just need my d, and my d was given to me. It's a phase shift of 5 pi by 6, so I know, and it says to the right, so my d is positive 5 pi by 6. So I'm golden now. All I have to do is put this into the equation that I've got here. So we could say this is f of x or y, it doesn't really matter. A is 4, it's a sine, so I'm just going to say sine. And then I've got my k, which is 3, and then my x, and then my phase shift, which is minus 5 pi by 6 when I change the sign, and my vertical displacement, which is plus 1. Okay? All right, I want you to pause the video and try the next one on your own. All right, here we go. This one's cosine, so I'm just, again, going to find my a, my k, my c, my d. I'm going to say f of x equals a cos k times x minus d plus c. All right, here we go. A is equal to, I won't write the formula out, you know it's max minus min, so it's going to be 3 minus 1 over 2. So A is going to be 4 over 2, so A is 2. C, 3 plus minus 1 over 2, of course. So c is back to 1. And we know our k is going to be 2 pi over 5, and that's all you have to do, right? You can't simplify that anymore. So k is in terms of pi this time because our period was a real number. And then our d, it's a phase shift of 3 rads left, so it's going to be minus 3. All right, let's put that all into an equation. So we're going to have f of x equals 2 times the cos of 2 pi by 5 times x plus 3 plus 1. Okay, not hard, right? All right, let's keep on going. Hey, wait a minute. It was negative. Yeah, okay, sorry. All right, we're going to do a word problem now. Now again, these are, instead of just sort of feeding you the information this time, you've got to pull it out of the description of the word problem, okay? But it's really not that difficult. And again, you're always thinking A, K, C, D. Those are the components that you need to make the equation up. Okay, so on a typical day at an ocean port, the water has a maximum depth of 28 meters at 6 a.m. and the minimum depth of 9 meters occurs 6.8 hours later. Determine an equation for the depth of water at time t hours. Consider t to represent the number of hours since 6 a.m. So, on the ocean, in some parts, there are tides, right? So, you're going to have a varying depth of water over a certain period of time. So, we know the max is 28 and the min is 9. So our A is going to be 28 minus 9 divided by 2. So our A is going to be 9.5. And this is meters. So I want you to put that in because it's a real world problem, right? So we need to put the units in. So that's our amplitude. Our C, which is our vertical displacement, is going to be 28 plus 9 divided by 2, which I believe is 18.5 meters. So far so good. I've got my A and my C. Now, let's think about the K. K is our phase shift. And our phase shift is really, we want to think about whether we're going to use cosine or sine, and we're going to think about whether we need to have a phase shift or not. And so my word of advice to you in class was avoid a phase shift wherever possible. So over here, it's saying that it's starting at 6 a.m. and it's at its max. And if we're considering that at 0 hours, when t is 0, that's 6 o'clock, right? No hours have passed and it's 6 a.m. And we know that at 6 a.m. we're at our max. So if I'm starting this sinusoidal curve at its max at t equals 0, which is the y-axis, I know I'm going to use cosine. And if I use cosine, I don't need a phase shift because cosine is supposed to start at its max. So I'm going to say, whoopsie, why did I say k? This is d, my phase shift. So d is going to equal 0 if we use cos. Okay, and you always want to try and avoid a phase shift. Okay, and my k is my number of cycles over 2 pi. And my k, of course, is derived from my period. So let's see if we can figure out what the period is first. So again, I'm going to erase that. So the period is going to be the length of time it takes for one cycle of this to happen. So what will happen in this particular cycle is it will go from its maximum down to its minimum depth and back up to its maximum again. And the time it takes to do that is going to be, of course, double the 6.8, because the 6.8 hours is the length of time it takes to go from its max to its min. And that only represents, if you look at the graph of cosine, That's half the period, right? This is one full period. To go from max to min is 1/2 of the period. So the period is going to be 2 times 6.8. So the period is 13.6. What is this? Well, it's the x-axis, the units, and so we know that's hours. Okay, and if we know our P, we know our K. So we're going to put in 2 pi over 13.6. And we want to keep this exact. So what we would do is leave this as 20 pi over 136. So what I did there was I just multiplied this by 10 over 10 to get rid of the decimal. We don't like to mix fractions and decimals. So in multiplying by 10, I got this to be 136 on the bottom, so I don't have any decimals anymore. And I'm now going to just simplify this fraction, and it came out to, I think it was 5 pi by 34. 34 times 4 is 6. Yeah. Okay. So I've got my K, I've got my A, I've got my C, and I know the D is 0. So let's put it all into an equation. So let's just use the proper letters here. It didn't give us a letter for depth, but let's just use function notation and use d of t. We're using cosine. We decided that already. Our A is 9.5. My K is 5 pi by 34 times my variable t, and then the only other thing I need to put in there is my displacement. There we go. Okay, so that's an equation that represents the depth over any particular number of hours since 6 a.m. If I want to sketch this sinusoidal curve, then all I'm doing is we're going to just, because we don't have a phase shift, we don't even have to go through this business that I taught you yesterday. All you want to do then, it really is just put your quarter period on the x-axis. So our period was 13.6. A quarter of that, let's just do that, is 3.4. So I'm going to break it into 1, 2, 3, 4. There's 3.4. Double that, 6.8, add on another 3.4, and that's going to be 10.2, and 3.4 is 13.6. Okay, and now on my y-axis, I go from a maximum of 28, I think it was, to a minimum of 9. So I'm just going to make sure I have 1, 2, 3. I'm going to go up then by 7s. So 7, 14, 21. Okay. So now I know that I started off here and I was at my max. The water was at its max. So actually, before I do this, I'm just going to go back and I'm going to label the x and the y axes. So you want to put, because this is a word problem, you want to actually label it with some words. So these are nice real numbers and they represent something now, right? It's not an angle. This is the number of hours since 6 a.m. And this is the depth of the water in meters. And now I know that, okay, at 6 a.m., 0 hours had passed and the water was at 28 meters. Over 1/4 of my period, I knew that it was going to go down to my equation of my axis, which is 18.5. So let's just, if I had kind of drawn that's looking a little like it's falling, but anyway, use your imagination. Here we go. That's my, over a quarter period, I go down to my equation of my axis. Then I am going to go down to my minimum here. And then over one more quarter period, I'm going to be back up here. And then at 13.6, I'm going to be back up at my maximum. This is one cycle of this curve. I'm going to just do this. I'm going to put an arrow on. It will continue on forever in that direction. A number of hours, we could consider that there were negative hours, but I would say stick in the positives here. 5 points labeled as per usual. So this is going to be 0, 28, 3.4, 18.5, 6.8, and 9, 10.2, and 18.5, and last one is 13.6 and 28. Okay, labeled my 5 points. I should put the equation on there, and then I'm good to go. Okay. All right. The other expectation that we have for this particular section, it's really a lot going on here. You do have to come up with the equation from a graph as well. So instead of giving you the description, the max, the min, etc., we're just giving you the graph, but you really do have to do the same thing, right? You have to figure out what the max and the min are. You can do it by identifying it and picking it off the graph and then using your formula, or if you really just want to figure out your amplitude by looking at where this graph is cut in half horizontally and then counting up or down to your max or your min to figure out your amplitude, you can do that. But I mean, the tried and true really is just figure out your max and your min and then use your formula. So it's going to be 1 for my max minus my min, which is -5 divided by 2. So this is 6 divided by 2. So I know my A is 3, and if we can verify that, we should be able to go up 1, 2, 3 units then to get to our max, and we should be able to go down 1, 2, 3 units to get to our min. So I'm glad that's right, because I know my A is correct then. So, okay, C is equal to 1 plus -5 divided by 2, so that's -2. Well, that makes sense because that was at -2, right? So far so good. I've got 2 pieces of my puzzle. I need my K and I need my D. So let's do the equation in terms of cosine first. So for cosine, this is what you do. You go to your max that's closest to the y-axis. You can see that occurs right here. Now normally cosine starts here and continues like this, right? So we know that the original cosine has been shifted by this much. So this amount right here is our phase shift. All right, let's see how many units that is. Well, I don't have my scale indicated for every increment, but I can figure out what it is because I go over 1, 2, 3, and I get to pi, -pi in this case. So I know that each one of these is going to be -pi divided by 3. So -pi, 1 pi by 3, -2 pi by 3, -3 pi by 3. Okay? So I know that my D is going to be -2 pi by 3. Okay? 1, 2. And I know that my K comes from my period. And I can tell what the period of this function is. It's the distance between the 2 maxes. Okay? It can be, you can figure out the distance between the two minimums. You can figure out the distance between the max and the min, this distance here, horizontally, and then double it. That's fine too, okay, whatever you want to do. But if you've got the 2 maxes, that's the easiest one. So you got to identify this one now. Let's see, 3 pi is the same as 9 pi by 3, so we have gone 9 pi by 3, so this next one is 10 pi by 3. Okay, and this one is -2 pi by 3. So I know that my period is going to be 10 pi by 3 minus -2 pi by 3, right? You just take the difference between these two to get the length. So 10 pi by 3 plus 2 pi by 3 is 12 pi by 3, better known as 4 pi. Okay, so I have the period. I have my my A and my C and my D. So all I need to do now is figure out what my K value is. So K is going to be 2 pi over P, which is 2 pi over 4 pi, which is a half. When I cancel the pi's and reduce the fraction. So my first equation, maybe I'll put it up here, is going to be y equals, or f of x equals, let's see, 3 cos 1/2 bracket x plus 2 pi by 3, that's my phase shift, and then plus, no, it should be minus 2. Sorry, that's a mistake there, so go back and fix that, please. That's my bad. Hopefully you picked that up while I was babbling on. Okay, so this is going to be minus 2. Okay, so that's cos. So just the big thing is go to where your max is closest to the y-axis and figure out your phase shift from there, okay? All right, now for sine, it's a little bit different. So what we do for sine is we draw our equation of our axis in, our new one, right? It's not the x-axis anymore, it's c equals -2. And so down here, I've drawn in my equation, my axis already, and I know that sine looks like this, right? It looks like this portion right here, with ending here and starting here. That looks like the sine curve to me. And so when I draw that portion in, I can see that my phase shift is really this amount right here. That's how much, if this had started over here on the equation of the axis, that's how much it's been shifted. Okay? So that's one way to do it. That's my k value without a reflection. So I'm going to say, not my k value, my d value. So my d is going to be, if it goes to here, it's going to be 1 less than 2 pi, which was 6 pi, but negative 6 pi by 3. So this is going to be negative 5 pi by 3 here. And so my phase shift is going to be for sine. So this was all for, maybe I'll use a different color here. So for the black one is going to be for sine. We're going to have everything else the same, but our k is going to be equal, sorry, not our k, gee whiz, I'm tired. My d is going to be equal to negative 5 pi by 3. Everything else, our k, our a, and our c stays the same for sine. So up here, I'm going to write y equals 3, same sine, same half times x, and instead of 2 pi by 3, we're going to have 5 pi by 3, change the sign, and this is going to be minus 2. Now, the other thing that you can do, because when I look at this, I can see that right here where the graph is actually starting, if the graph had started here, it would have been decreasing and then increasing. This would be as if sine had been reflected at the beginning. So if we had started here and just gone down from the beginning, that would have been just regular old sine curve, but with a reflection. So if I wanted to incorporate the absolute smallest phase shift, I would consider that to be my smallest phase shift, which of course is just positive pi by 3. So another option here, with a reflection, we can say our d is going to be positive, this is happening again, positive pi by 3. Okay? And then what we would do now is say, or y equals 3 sine, negative 3, with the reflection, sine 1/2 x minus pi by 3 minus 2. Okay? I will accept either of these two answers. I would have accepted, this one's the easier one, I would have accepted the phase shift from here to here, from here to here with a reflection for cos as well. But this one was closer, so it was easier to take the max and just figure out what the phase shift was there. Okay, that's it. That's all. Thanks for listening. Good night.